Hello geometry students. Today we are going to learn about compositions of transformations. Compositions of transformations is just a fancy way of saying that we are going to do more than one transformation to the same shape. So we're going to start by recording the coordinates of the vertices of the original triangle SPY in this table. S is at negative 1, 2, 3, 4, 5, 6. Positive 1, 2, 3. P is at 1, 2, 3, 4. 1, 2, 3, 4. And Y is at 4, negative 1, 2, 3, 4, 5, 6, 7, 8. 4, negative 8. Now, it says on the graph above, translate the triangle 4 units up and 6 units to the right using the vector 4, 6. So 4 in the little chevron symbols, which are the pointy parentheses, means that the x-coordinate is going to go up 4 and the increase by 4, which will make it go to the right 4. Oh, this is backwards. Okay, 4 units up and 6 units to the right. So this should be the 6 and this should be the 4 to match what it says here. So 6 units to the right and 4 units up. So let's do this. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So here's S prime, that's 4 units up and 6 to the right. P prime is going to be 1, 2, 3, 4 up. 1, 2, 3, 4, 5, 6 to the right. There's P prime. And Y is 1, 2, 3, 4 units up. 1, 2, 3, 4, 5, 6 units to the right. So there's Y prime. And now we can connect these using our ruler. Okay, and we need to record the coordinates of our new image, S prime, P prime, Y prime. So S is at 0 for the X, 7 for the Y. P is at 10 for the X, 8 for the Y. And Y prime is at 10, negative 1, 2, 3, 4. So, what happened to the x-coordinates under the composition of transformations? Negative 6 changed to 0, 4 changed to 10, 4 changed to 10. So, they increased by 6 units. What happened to the y-coordinates under the composition of transformations? 3 became 7, 4 became 8, negative 8 became negative 4. So they increased by 4 units. So now we have to write a transformation rule that describes this composition of transformations. So the x we do plus 6, and the y we do plus 4. Are triangle SPY and triangle S prime, P prime, Y prime congruent to each other, similar to each other, or neither? They are congruent. They're the same size and the same shape. By moving it up and over, we did not change the shape. All we did was change the location. So that's a congruence transformation. All right, next. It says record the vertices of the original quadrilateral KIDS in the table below. So K is at negative 6, negative 3. I is at negative 2, negative 2. D is at negative 1, 2, 3, negative 6. And S is at negative 7, negative 7. So it says on the graph above, reflect the quadrilateral across the line y equals negative x. So if you'll remember, the line y equals x is the parent function of a linear function that you learned in Algebra 1, and it's the one that goes like this up through the diagonal corners of each unit square from the origin, up 1 over 1, up 1 over 1. But we're not doing that one, we're doing y equals negative x, so that means over 1, down 1, over 1, down 1, and you draw it through those diagonal corners of each. See if I can get this lined up carefully. Oh, there we go. Of each unit. Yes. So that's the line y equals x. Y equals negative x, sorry. Y-intercept is 0, and the slope is down 1 over 1, down 1 over 1, down 1 over 1. Okay? So first we're going to reflect it across this. How do we reflect across a diagonal line? Well, we look at how far away is each point from the line and go that same distance away on the opposite side. So the closest one to the line is the eye, and it's 2 diagonal jumps to the line. So I go 2 diagonal jumps on the opposite side of the line and do an I prime. Now for K, we go 1, 2, 3, 4 and a half diagonal jumps. So then I'm going to go a half and 1, 2, 3, 4 diagonal jumps to get to K prime. S is 1, 2, 3, 4, 5, 6, 7 diagonal jumps. So 1, 2, 3, 4, 5, 6, 7 diagonal jumps. There's my S prime. And D is 1, 2, 3, 4 and a half. So a half and 1, 2, 3, 4 diagonal jumps from the line. So there's okay, and this is not the final shape. This is the kind of like a middle shape. Because we're doing a composition of transformations, we are doing more than one transformation to the shape. So this was a reflection. That was our first transformation. Next, we're going to do another transformation, which is 4 units down. So actually, I probably shouldn't have labeled this K prime, I prime, D prime, S prime, because the final one is after I scoot this 4 units down. So for each of these, I'm going to go down 1, 2, 3, 4. There's my actual I prime. 1, 2, 3, 4. There's my K prime. 1, 2, 3, 4. There's my D prime. And 1, 2, 3, 4. There's my S prime. So now I'm going to connect these to form the actual K prime, I prime, D prime, S prime shape that I'm recording the coordinates for in my table. So K prime is at 3, 2. I prime is at 2, negative 2. D prime is at 6, negative 1. And S prime is at 7, 1, 2, 3. Okay. So they want us to talk about what happened to the x coordinates under the composition of transformations. This is a little bit challenging to do, to go from the original to the one that has 2 transformations. So I strongly recommend that to figure this out, you record the middle step as well. See, the K prime originally was at 2, 2. How? No, that was not the K prime. I apologize. That was the I prime was at 2, 2. The K prime was at 3, 6. And the S prime was at 7, 7. and the d prime was at 6, 3. So how did these numbers compare to the original? Well, the x and the y switched places, and they both changed signs. So it was like it was negative y, negative x. That's how the function rule happened first. So then the next thing that happened to get from here to here, 3, 2, 6, 7, the x's stay exactly the same, but 6 goes to 2, 2 goes to negative 2, 3 goes to negative 1, and 7 goes to 3. So those subtracted 7. So it'd be like negative y, negative x minus, not 7. 7 became 3, minus 4. We subtracted 4. Let me write that neater. Negative y, negative x minus 4. So, what happened to the x-coordinates? The x-coordinates became the opposite of the old y-coordinates. Or the y-coordinates multiplied by negative 1. Then what happened to the y-coordinates under the composition of transformations? They became the opposite of the x-coordinates, subtract 4. So they are the old x-coordinate multiplied by negative 1, and then subtracted 4, subtract 4 from them. Okay, so the transformation rule that would describe this composition of transformations is negative y, negative x minus 4. And then it says R parallelogram KIDS and parallelogram K prime, I prime, D prime, S prime congruent to each other, similar to each other, or neither. They are congruent. They're the same size and the same shape. They have just moved on the coordinate plane. A reflection and then a translation. Okay. The next one says to record the vertices of the original triangle WIN in the table below. So W is at 1, 1, I is at 2, 3, N is at 3, 1. It says on the graph above, dilate the triangle using a center of dilation of 0, 0 and a scale factor of 3. So we're going to multiply everything by 3. So it'll become 3, 3 for the new W. The new I will be 6, 9. The new N will be 9, 3. Then translate it 7 units down to become triangle W prime, I prime, N prime, and label the corresponding vertices W prime, I prime, N prime. Okay, so let's do the middle shape first. 3, 3 is where our W is going to be. I'm not going to put the prime by it this time because I'm not going to make the same mistake I did last time. I'm going to wait to the last one to put the primes on it. And then 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my I. And then 9, 1, 2, 3. There's my N. So here's my middle shape. This is not the final. This is the dilated shape. So I've done the dilation. All the coordinates are 3 times as big as they were originally to make this shape. But I have one more transformation to do, which is a translation 7 units down. So I'm going to count 1, 2, 3, 4, 5, 6, 7. There's W prime. 3, negative 4 are its coordinates. Then I is 1, 2, 3, 4, 5, 6, 7. There's my I prime. 6, 2 are its coordinates. And then n, down 1, 2, 3, 4, 5, 6, 7. N prime is at 9, negative 4. Okay, so here's my final shape under the composition of the two transformations, the dilation and the translation. And, oops, I don't think I drew that very good. There we go. So, what happened to the x coordinates under the composition of transformations? Well, the 1 became a 3, the 2 became a 6, and the 3 became a 9. So they were multiplied by 3. They were multiplied by 3. What happened to the y coordinate under the composition of transformations? Well, first it was multiplied times 3. Then 3 became negative 4, 9 became 2, and 3 became negative 4. So we subtracted 7. So they were multiplied by 3 and then subtract 7 from them. So write a transformation rule that describes the composition of transformations. This would be 3x and then 3y minus 7. Are triangle WIN and triangle W prime, I prime, N prime congruent to each other, similar to each other, or neither? Well, they are not the same size as the original shape. They are the same shape, but not the same size. So that's those words similar. Similar shapes are the same shape, but not necessarily the same size, like congruent ones are. Okay, that concludes our practice with compositions of transformations. We haven't learned any new transformations today. We've just learned how to do more than one transformation to the same shape. So, good luck with your homework assignment. Please let me know if you have any questions, and have a great day. Bye for now.